Welcome to Professor Gunawardena's podcast on AI and data science. I am Professor Guna. Today, I want to discuss the evolution of AI or artificial intelligence. I will invite my AI friend Jessica to discuss this with me. So, Jessica, let's get started. Artificial intelligence has evolved from simple calculators to machines writing poetry and creating art in just a few decades. But here's the wild part. Most people have no idea that AI's roots stretch all the way back to 1956.
That's fascinating how you put that timeline in perspective. The journey from those early computing concepts to today's AI systems really shows how far we've come.
You know what's really mind-blowing? Those first AI systems were basically just glorified decision trees. Imagine having a computer that could only follow the most basic if-then instructions, like a really primitive choose-your-own-adventure book.
Well, that reminds me of those early medical diagnosis systems. They would just follow these rigid pathways. If fever, then check for symptom A. If no fever, check for symptom B. Seems almost laughably simple now.
I agree. Here's what's really interesting, though. Even with those limitations, these systems were revolutionary for their time. They could process information faster than humans, even if they couldn't think creatively or adapt to new situations.
That makes me wonder, how did we get from those basic systems to what we have today?
Well, it's quite a roller coaster, actually. The 1980s saw this massive AI boom. Funding was everywhere. Researchers were making breakthrough after breakthrough. But then something interesting happened. Reality didn't quite match up to the hype. We did not have the computing power or data or algorithms to make progress rapidly.
Sounds like what we might be experiencing now with some AI promises. History does tend to rhyme, doesn't it?
Absolutely. But then in 1997, we hit this huge milestone. IBM's Deep Blue defeated world chess champion Garry Kasparov. Though here's the fascinating part. It wasn't really thinking like we do. It was just processing this massive database of chess moves at incredible speeds.
That's such an important distinction about Deep Blue. People often assume it was some kind of artificial consciousness, when really it was just incredibly fast pattern matching.
And now, look where we are. We've got AI systems that can generate art, write stories, and even compose music. The leap from those early decision trees to today's generative AI is just staggering.
See, Professor Guna, let me add something interesting about that evolution. We've moved from systems that could only recognize patterns to ones that can actually create something entirely new.
Speaking of which, let's break down these different types of AI because I think there's some confusion out there. Right now, most of what we use is narrow AI, incredibly good at specific tasks, but completely lost if you ask them to do anything else.
That's like having a world-class sprinter who can't even walk backwards, right?
Exactly. And then there's this whole concept of general AI that everyone's talking about, systems that could potentially think and learn across different domains just like humans do. But we're not there yet, and some experts think we might be decades away.
Though the progress we're making is pretty remarkable. Just look at how ChatGPT and similar systems have changed the game in the last few years.
You know what really keeps me up at night? The concept of superintelligent AI, systems that could potentially surpass human intelligence in every possible way. It raises some pretty profound questions about consciousness, empathy, and what it really means to be intelligent.
Well, that brings up an important point about ethics and safety. How do we ensure these systems remain beneficial to humanity?
That is a good question, Jessica. Also a very hard question that many people are thinking about. Now let's talk about the building blocks of modern AI. Machine learning is this incredible approach where computers learn from experience rather than following strict programming. It's like teaching a child to recognize animals by showing them examples instead of giving them a rule book.
And then deep learning takes this even further by trying to replicate how our brains process information. Right?
Absolutely. Neural networks are particularly fascinating because they're inspired by the actual structure of our brains. Each artificial neuron is connected to others, forming this complex web that can process information in increasingly sophisticated ways.
That really makes you think about the future possibilities. Where do you see all this heading?
Well, I think we're just at the beginning of something extraordinary. AI is already transforming healthcare, scientific research, creative arts, but the potential for solving some of humanity's biggest challenges, like climate change and disease, that's what really excites me.
Though we should probably keep in mind both the opportunities and the risks as we move forward with this technology.
Yes, looking ahead, I believe we're going to see artificial intelligence continue to evolve in ways we can barely imagine right now. The key will be ensuring that we guide this development in ways that benefit humanity while managing the potential risks.
Let me leave us with this thought. AI isn't just about the technology anymore. It's about how we as humans choose to shape our future alongside these increasingly capable systems.
So that is all for now, folks. Jessica, thanks for your thoughts on this topic. Let's do another exciting episode on predictive AI next. Until next time.